podcasts on Think Tech Hawaii, broadcasting from studios in Pioneer Plaza. This is a live network series here. I'm your host, Ethan Allen, and just want to say a few words about this new series that we have, Likeable Science. We're trying to promote the idea here that science is really very accessible and very much part of everyone's lives. So the idea that science, technology, engineering, and math are these foreign subjects is really an out-of-date and incorrect concept, and I want to, over the next upcoming weeks and months, help people understand a little better that science is basically fun. There's a lot of fascinating, very cool stuff happening related to science, technology, engineering, and math. And I have tried to line up a number of guests to help me make that point, get that point across. Towards that end, today we have Howard Wiig here. Howard is an energy analyst with the Strategic Industries Division from the Department of Business, Economic Development, and Tourism for the state of Hawaii. Welcome, Howard.
Thank you.
So, Howard, I'm a little bit curious as to what it is that an energy analyst does.
Okay, well, let me give some background about the State Energy Office. We're part of the Department of Business, Economic Development, and Tourism. And the reason we're in that department is that what we do with our energy use is directly related to the economic well-being of the state. It used to be that we exported as many as $8 billion a year, and our gross state product is only $72 billion, $8 billion a year to oil exporters. That was a huge chunk of our gross state income. We in the Energy Office are working to, number one, develop renewable energy sources, and number two, part of my kuleana, to reduce energy use in buildings so that we can keep more of those dollars at home. And that, in a broad sense, is what an energy analyst does, is get buildings and homes and transportation more and more efficient. You get more miles per gallon out of whatever it is you're dealing with. That's my job, and that's an exciting job.
It sounds very interesting, yes. Mm-hmm. And I understand there is now a new push to recognize the climate that we're in, this tropical climate zone, mm-hmm. as it were, as a sort of separate situation that needs its own mm-hmm. sort of rules and regulations about energy and building codes.
Absolutely. I am the energy codes guy for the state. When you build a new home or new building, you have to go through a series of hoops in conforming to codes. Your seismic code, so the building doesn't fall down, fire code, plumbing code, and so forth. And there's an energy code. And the reason that is very important is if you build, say, a home in a wasteful fashion, your utility bill might be, say, $300 a month. You build it in an efficient way, your utility bill goes down to, say, $150 a month. You cut that in half. The way we've been dealing with the energy code in the past has been to take the mainland code, national, and then tweak it to Hawaii. I was just in Atlantic City at the final hearings of the energy code meeting, and we passed a whole separate climate zone called the tropical climate zone. So now we in the tropics can start from the ground up designing homes and buildings exactly the way we want to, that makes the most sense for the tropics. We can get cooler, more comfortable buildings at a fraction of the energy costs that would be the case if we designed to mainland standards.
Excellent. Well, that sounds like something like a worthwhile goal.
Mm-hmm.
And it seems to me that's going to be increasingly challenging as our climate in this region mm-hmm. around the world changes. I understand, for instance, that the trade winds, which used to blow close to 300 days a year, now are down to only 220 days a year. Mm-hmm. There's more sort of still days when things get hotter. Mm-hmm. So this must then impact how you'd ideally build a building.
Absolutely. We're going to pay more and more attention to keeping the heat out of the building in the first place. And just by the by, I live in the back of Manoa, a very cool neighborhood. In the winter months, I used to have my usual blanket and then an extra blanket on the bed. This winter, I have not needed that extra blanket, and people I talk to go through the same experience. This winter is not nearly as cool as it used to be, which means we have more heat, which means we really need to study how heat gets into our homes and our buildings and keep that heat out in the first place.
Exactly. And it seems this has larger ramifications too. As the climate shifts, there are sort of changes other than just strictly temperature change. The rainfall patterns may change, the storm patterns might change. So all of these might impact energy use too in various ways, right?
Absolutely. We are getting less rainfall than we used to. So I work closely with the plumbing code people, and two things we're doing is working into the plumbing code the fact that you need to catch the rainwater that falls on your roof and use that for your outdoor landscaping opportunities. That's a huge, huge, huge saver right there. This is just wiser use of water. And then number two, we haven't gotten there yet, but what I would like to see from a water standpoint is requiring permeable surfaces, where instead of having a hard driveway, you have something called like porous concrete, where the rainwater falls onto the driveway and goes through down into the water table. So we're going to be looking, given climate change, more and more at water efficiency combined with energy efficiency.
I see. Yeah, and that seems to make sense. The issues of rainwater catchment that you were just talking about are a very big deal certainly in the outer U.S. affiliated Pacific Islands. I'm currently working on a project there, trying to promote more and better rainwater catchment, because the folks there actually rely on it for their drinking water. Since they have, in many of those low islands, particularly no groundwater at all to speak of. Here, I understand there are some issues with how you use your caught rainwater and what you're sort of allowed to do with it.
Yeah. The big concern that the Plumbers Union has as we move into this field is they don't want non-potable, non-drinkable water being inadvertently diverted indoors and being treated as drinkable water, because the plumbers, would be held liable. So we're going through a huge issue about ensuring that different pipes have different colors, so that even if an outsider comes in and starts working, he knows that's non-potable, that's potable. And that puts the plumbers' minds more at ease, so that they're comfortable with these new provisions.
Excellent. That seems like a very sensible idea to implement then. Then could you maybe talk a little bit more though about things like the use of air conditioning here? Why people will over air condition here and have rooms that everyone comes into and then has to put on overshirts or scarves because the rooms are freezing? Why don't they just open the rooms up and get some breezes through them?
Okay, this is again what we deal with the energy code all the time. And over air conditioning is just simply a matter of education. You don't need it that cold. You don't need it to set it at 68. 75 will do quite well. Thank you very much. For every 1 degree you turn a air conditioned temperature up, you reduce your energy use by 2%. So you turn it up by 10 degrees, you reduce energy use by 20%. Very, very substantial. What we attempt to do, what we do in especially the residential energy code, is ensure that a minimal amount of heat gets through the roof, minimal through the walls, minimal through the windows, and there's high technology to address all of that. And then we require a given amount of window space, openable window space, in the home, so that on a nice cool day or a cool night, you can open the windows up, shut your AC off, and just enjoy the trade winds. Ideally, you would use your AC only during really hot days.
That certainly makes sense. It's, in my few years of living here, so far I've only rarely had to have the air conditioner on. I've been fortunate enough to live in places that have good ventilation, catch good breezes, and that makes a tremendous difference. Well, I'll tell you what, I think we better go to our first break here. So again, I'm Ethan Allen. I'm the host of Likeable Science here, and here with me is Howard Wiig from the Strategic Industries.
Call it the State Energy Office.
State Energy Office.
We're calling it
all
that
right.
now. Yeah.
We'll do that. Thank you very much. We'll be back shortly.
Aloha, I'm Nicole Horry for ThinkTech. For nearly half a century, the Hawaii Foreign Trade Zone No. 9 has brought the benefits of the Foreign Trade Zone program to Hawaii businesses and entrepreneurs. DBEDT, the Department of Business, Economic Development and Tourism, operates Hawaii's Foreign Trade Zone program to encourage international business and economic development. The Foreign Trade Zone's mission is to increase the amount of international trading activity in Hawaii, thereby providing employment opportunities for the residents of our island state. For more information, see ftz9.org. I'm Nicole Horry. Mahalo.
We're back. I'm Ethan Allen, and this is Likeable Science here on ThinkTech Hawaii. My guest today is Howard Wiig, an energy analyst for the State Energy Office, and we're talking about energy use and the impacts of climate change here in Hawaii. So, Howard, I wanted to follow up on what we were just talking about before and get down to some sort of hard numbers here. So, the predicted increase in temperature, changes in our climate, have people estimated how much that's going to impact energy use in terms of the kilowatt hours or the dollars that it's going to cost us?
Not in those terms. We don't say that when the temperature rises 1 degree, you will have a 2% increase in energy use. But what we do, a more heavier duty impact of rising temperatures is, of course, rising sea levels. And there's a fellow named Chip Fletcher, who I imagine has been on this program, or on ThinkTech, and he certainly has predicted the impact of the rising sea levels. And incidentally, on the North Shore, if you or I were to go out there right now, I would think we would see more and more erosion because of these huge waves going up. So that's the major source, the major impact from rising sea levels and rising temperatures. But yes, we will live in a warmer and warmer climate, and there will be probably in those areas that don't get much rainfall, they may get even less rainfall. And we've got to plan for all of that.
And so what is the State Energy Office doing in the way of trying to set plans or priorities or strategies to help us deal with this?
That's a question after my own heart. In 2008, then Governor Lingle signed an agreement with Hawaiian Electric Industries and the U.S. Department of Energy saying that by the year 2030, which is only 16 years away, Hawaii will have 70% clean energy. And that means clean energy is a renewable energy like solar or wind, or it is efficiency, reduced energy use. The electricity we were using, we're no longer using. That's wiped off the map. And we are succeeding in that. Hawaiian Electric plans in just the next few months, I think it is, to shut down their downtown power plant, the one by Aloha Tower. Why? Because we are indeed decreasing our electricity use. And it's not because we're sweltering in our homes, it's because we're making much better use of every BTU of electricity that we get now. And that is largely due to better building codes, better energy codes. So we're moving aggressively. We have one of the most ambitious energy goals of all the states in the Union. Some are actually copying us. And we, so far, are ahead of schedule in meeting that goal of 70% clean energy by 2030.
Excellent. I do understand there's some issues these days with the increased use of solar power. Some neighborhoods are getting a great deal, a great many of the houses in the neighborhood, for instance, are having solar panels, so much so that the local power company is having some issues and troubles on. Could you elaborate on some of the challenges they face, maybe?
Yeah, just as our human bodies need to function under something called homeostasis, where it's the Goldilocks theory, we're not too hot, we're not too cold, we're right where we should be. When you deliver electricity, there's a very, very narrow band of wavelength that you can deliver. It's something called 60 hertz. If you go above 60.5 hertz, below 59.5 hertz, the electricity becomes dirty, and sensitive equipment like computers can be adversely affected. So one of Hawaiian Electric's main jobs is to keep within that very narrow band of clean electricity. When you have too many photovoltaic power plants scattered throughout the island, you may be having a huge amount of solar energy one moment, boom, a great big cloud comes over, and that electrical production drops like a rock. Now what? That is what Hawaiian Electric is facing. It has to suddenly ramp up the oil-fired facilities to meet that vacuum, and then when the cloud goes away, production goes up, it has to ramp it back down again. The current power plants aren't equipped for that rapid response. You can do it with batteries. Batteries are expensive. Batteries are improving all the time. We're not quite there yet. And Hawaiian Electric is looking at something called microgrids, where you separate areas by neighborhoods and you monitor the fluctuations of the power, and then you regulate it through technology such that when the cloud goes over, production goes up, cloud goes away, production goes down, so that you have this nice even flow of electricity. This is the dilemma that Hawaiian Electric is confronting at the moment. We have the technology, but the technology costs money.
Right. It seems to me, at the very least, you're putting an extra link in the whole step if you need to somehow buffer that direct solar power and stash it in a battery so you can feed it out in a very even and regulated fashion.
And instantaneous. It has to be just like that. You can't even wait for a second. It has to be a split-second response.
Right. Right. The system must be very, very finely tuned for its homeostasis to work, as you say.
Yeah.
Okay. Well, that's intriguing. And then when you add in yet more alternate sources like wind power.
Precisely.
Right.
The wind comes up, the wind goes down, same situation.
It should all average out, you know?
It should average out ideally, and it doesn't. Yeah.
Excellent. Are there more different energy sources being sort of on the horizon here? I know some of the islands are talking about using wave power. Are we doing much of that here in Hawaii?
We have we're one of the wave power research centers of the world, and we have looked at something like 12 different types of wave power, and it's certainly not my area of expertise, but I believe all 12 of those sources have failed in some way, shape, or form. There's all of these contingencies, like algae and other sea growth attaching itself to the bottom side of these, adding to the weight, decreasing the flexibility, fish gathering under the devices, fishermen coming right around the devices, all kinds of things go wrong. And there was a really good test facility off of Kaneohe Marine Air Corps Station, and they were monitoring that. The results were not all that good. I haven't been following it, but I would put wave power out there somewhere. And there are other technologies like fuel cells. They are out there. And an immediate source, though, is, believe it or not, electric vehicles. We think of electric vehicles as just taking up electrical power. Well, when you plug them back into your home unit at home, if you arrange with Hawaiian Electric, if they need extra power, they can actually drain the electric vehicle battery and feed it into the grid. Now there's a near-term source.
Wow, that could probably be disruptive too when you jump in your car and
Yes,
try to
yes, you
drive
have
off.
to make sure that you get to recharge the battery before you. And incidentally, battery technology is just improving. Finally, we've been waiting for those breakthroughs. Those breakthroughs are occurring, and that's really going to help us in evening up this power source.
Right, it's that mix of having the ability to release a lot of power quickly versus storing it well for over the long term, and how you balance those two things out, as I understand it. That's
I just met yesterday with a fellow who's back from Korea, and the Koreans have developed a new type of PV powered light where instead of needing a battery, your capacitor can store the energy that's produced during the day to feed it into the light at night. The capacitor instead of a battery. That is absolutely revolutionary. It works. This is how rapidly the technology is changing, and if this catches on, that's going to make big improvements for us.
Yeah, this is the whole area of molecular engineering, where the material scientists are now able to structure materials in very precise ways and to give it just the properties
Precisely.
you want. And that's a huge exciting
Yeah, we
area.
live in exciting times in that regard, yeah.
It is indeed a lot of challenges, certainly.
Yeah.
And the other part I wanted to talk about, though, was just good old-fashioned conservation. And is the Energy Office actively promoting?
Well, here's a little semantics for you. Conservation, those of us who have been around long enough to remember Jimmy Carter, remember that he preached conservation, and he sat there in a sweater in a darkened room, and that turned America off to conservation. We Americans don't like to do without. So instead of saying conservation, I like to say efficiency. Efficiency is most easily measured in a car's mile per gallon. You trade in your 15 mile per gallon car for a 30 mile per gallon car. You're getting from A to B just as effectively, but you're only using half as much gas. Apply that efficiency to everything across the board, and it's happening. Again, technological change, and it's really happening quickly. The average home, say 2,000 square foot home that's built today, will use only probably half as much energy as a similar home that was built 40 years ago, because of all these technological improvements.
Yeah, I know the groups like Blue Planet Foundation are very actively working to try to get people to switch out all the light bulbs wherever possible down to either LEDs or compact fluorescents. And I understand that basically it's going to shortly become very hard to find standard old incandescent bulbs at all.
Well, what has happened is people are so in love with their incandescents that they've hoarded them. So they will be around for a while, but people like Blue Planet and ourselves are going to do everything we can to get people to shift over. It used to be compact fluorescents, now it's LEDs. LEDs are just coming on like gangbusters.
I've just recently seen some myself, and actually have one in our house. I was sort of amazed to see this little thing with a number of small LEDs, and it's perfectly bright and gives a good quality of light.
Yeah, I could tell a lot of LED success stories because they're coming down the pike so rapidly.
And those, of course, are much more efficient. Your average incandescent bulb is only, 5% efficient, basically. Something like 95% of its energy is going into heat.
Yeah,
The compact fluorescent is
at least 6 times, if not 8 times more efficient.
right,
Yeah.
30 to 40% right.
Yeah.
Now, where does LEDs then stand on that? Would an LED bulb be even better than the...
Oh, I was talking about LEDs.
Oh, okay,
Yeah,
okay,
yeah.
yeah, all right. Excellent. So, are there other areas too? I mean, does this tie back into other home conservation, efficiency uses in terms of like water use? Does it?
Well, how about water heating? We're the perfect state in the nation for water heating because we have a good, strong winter sun. We're in the middle of winter right now, and we're in our aloha shirts. We don't even need long sleeve shirts. We have very, very strong sun throughout the year with solar water heating. You have your panels up on your roof. The sun's energy strikes it, And the panels are black so that the heat is absorbed. You run your water through it. You store that hot water in a tank. And the beauty of solar water heating is that we are very unique in being an evening peaking state. Most states have their peak electricity use in the summer between, say, 2 p.m. and 6 p.m. Our peak starts at 5 p.m. and runs to 9 p.m. Why? Everybody is going home from school, from work, into their homes, turning on everything. Fridge is going back and forth, stove is on, plus our tourist economy. All the tourists are coming home from the beach, coming home from shopping, tours. They get into their hotel rooms and everything is going full blast. Then they go down to the hotel, restaurants, and the bars. Everything is going full blast, and we have this evening peak. What happens with solar water heating is that when you come home at the end of the day, you have this nice tank of hot water just waiting for you. Your energy impact in using all that hot water is absolutely zero. Therefore, it shaves the peak, which is why Hawaiian Electric can shut down the downtown Honolulu plant now. We have over 100,000 solar water heating units in the state. If we could overcome certain obstacles, we could ratchet that up to 200,000, and the energy implications would be absolutely tremendous. Solar water heating is, in my personal opinion, better than photovoltaic because of its peak shaving capabilities, and it's more cost effective also.
Well, that's great. It's nice to hear we're so sort of blessed with the good fortune to be in that situation. Excellent. I think we're going to go on break again here. Again, I'm Ethan Allen. We're on Likeable Science. My guest is Howard Wiig of the State Energy Office.
We want to thank our underwriters.
Hawaiian Electric Company and its affiliates Maui Electric on Maui and Hawaii Electric Light Company on Hawaii Island are deeply committed to the communities they serve.
Galen Ho is a senior executive of BAE Systems, a global defense, security, and aerospace company.
The High-Tech Development Corporation, the state's leading technology agency, attached to the Department of Business, Economic Development, and Tourism.
Castle and Cook Hawaii, with a time-honored legacy that spans more than 160 years and revolves around its mission of investing in Hawaii, creating communities, and providing for the needs of our state.
Hawaii Gas, formerly the Gas Company, a proponent of the Liquefied Natural Gas Initiative, helping Hawaii achieve its transition to clean energy and a better energy future.
Collateral Analytics, a Hawaii-based tech company empowering the real estate industry with greater and faster access to the tools and data they need to make better informed property investment decisions.
I'm Nicole Horry. Thanks so much for joining us on Think Tech.
I'm Maria Kashem. See you next time.
We're back. I'm Ethan Allen, and we're on Likeable Science here at Think Tech Hawaii, broadcasting from downtown Pioneer Plaza. With me in the studio today is Howard Wiig from the State Energy Office. We've been talking about climate impacts on energy use, and I wanted to maybe look a little more broadly at your background, Howard. You're intrigued me when I read your resume because your training is all in literature and humanity or formal education. And so how did you make that shift into doing this exciting energy work?
I think I was born and blessed to be very, very thankful for a beautiful environment. I was born in Queens Hospital here, raised in Kahala. When we were kids, we'd just hop on our bike and say, "Mom, I'm going to Johnny's." And she'd say, "Okay, be back by dinner time." And we'd go zooming all over the neighborhood. We'd go wrestling on grass. We'd play football, the whole business in this beautiful outdoors. And when I was a teenager and going through all those troubled times, my dog and I would go down about sunset to Kahala Beach. And I was on the track team, and he and I would run back and forth, and I would be completely at peace with nature. And I think that made me into a true environmentalist. So even though I had my training in the soft arts, I instinctively knew that destruction of the planet meant destruction of all of us. And that was my passion early on. And another way I was blessed was graduating from University of California, Berkeley. And you don't do that without having a huge love of learning and an ability to learn things very, very quickly. Looking all the way back, I bless those days, so that when I got more and more into the environmental movement as it emerged, I caught on to things very quickly. I could understand scientific principles very easily, and I was offered a job at the State Energy Office just when it was starting, and the boss and I just learned on the job. And we expanded. Finally, the things that we were preaching 30 years ago are becoming mainstream today. So my job is to go out into the future and say, there's all this exciting stuff coming down. We can adopt it right now. And when you're in the soft sciences, you learn to speak pretty well. And so I have been able to be fairly persuasive in a lot of ways in bringing people over to a more environmental point of view.
I'm sure that's quite a challenge in and of itself.
Oh yes, oh yes.
People are very set in their ways. People hate to change. What are some of the other big challenges that the department faces, though?
Simply the fact that people don't like change. That's number one. Number two, I've done a study as to why everybody doesn't think the way I do. Because I know, I can see it, and the Nobel Prize winning scientists can see it also so clearly. The average person cannot. Why? We evolved to address only very, very short-term dangers. Like there's a saber-toothed tiger outside of my cave, I've got to kill it. And we were not evolved to address long-term issues. And that is the major, major challenge. We can talk till we're blue in the face about this statistic, that statistic. People don't get it until something like the North Shore, the erosion, porches are now falling into the ocean. People are now getting it because that's the short-term view, the short-term crisis. So unfortunately, we have to wait until crises hit. And then people say, oh, yeah, I guess Wiig knew what he was talking about. Yeah, we got to do something, yeah.
Yeah, that's certainly true. And I think you also hit on a bit of this earlier when you spoke of the importance of language in framing out a conversation, whether you use the word conservation or efficiency, and those trigger different thoughts in people's minds and different attitudes towards them. And so it must be the same kind of thing. In part, your job then, it seems, the department's job is to help people reframe these issues in more positive, more palatable terms.
Yeah.
Okay.
And there's 30 of us in the energy office, and all of us are working towards that goal. We each have our own areas of expertise.
Yeah, and you've also done some very different sorts of work in the past, I gather. You've written some articles on the issues of ghost net. Nets drifting in the ocean and the trouble that causes. I was intrigued with that in that you spoke of the sort of the energy savings by aggressively dealing with this problem, and it struck me as it's certainly a problem with great ecological consequences, but I hadn't understood the energy aspects of it. Perhaps you could elaborate on that.
Yeah, we started many years ago. The Energy Office has been through many, many iterations, and in the 1980s, we were privileged to start the recycling initiative. Back then, only 8% of all of the junk that was generated in the state was recycled, mainly old cars. Now we're up to something like 72%. That is a jump. And the energy implications are that it's a lot more efficient to melt down existing steel and remake it into something than to go into the earth, gouge out the ore, transport it, melt it down, so forth, so forth, so forth. So that's energy savings. So I became known as kind of the recycling guy. And then NOAA scientists, what's NOAA? National Atmospheric and Oceanic Agency, discovered on the northwest Hawaiian reefs these huge mountains of drift net and other marine debris that it was accumulating on the reefs and was swishing back and forth on the reefs during the winter storms and killing the reefs. And that's also the home of the monk seal, very endangered species. They'd go out and try to play in the net, they'd get strangled. And literally millions of seabirds were likewise getting strangled or ingesting things like bottle caps and cigarette lighters and so forth. So the scientists were harvesting that net and the other debris, bringing it back here. It was going into the landfill. Somebody called me as the recycling guy and said, can't we do something about this? And eventually, over the years, we formed a coalition between NOAA and Schnitzer Steel, largest steel processing plant on the island, and we would bring these mountains of net to Schnitzer Steel. They would cut them with their huge cutting machinery into sort of bite-sized chunks, like maybe the size of this table, and then take that to H-Power, our garbage energy plant, and burn that to make electricity instead of putting it in the landfill. And the material is basically plastic. Plastic has a very, very high heat content, so we're making all kinds of electricity, converting what was a great big problem into an electricity producing solution, all at no cost. Everybody was doing it voluntarily all the way down the line. It was an enormously successful program. It's emulated now on the mainland, and it won one of the top 50 Harvard Business School Innovative Awards of the year.
Excellent. Sounds very much like one of these, what they call collective impact ideas,
Yeah, yeah.
different groups with different goals and objectives get together and focus on a larger problem. Everyone contributes their expertise in a very strategic way. Wonderful. That's a very inspiring story. So, are there other things like that you can point to that you're?
Yeah, I sit on the Starlight Reserve Committee, and that was formed by the astronomy folks up on Mauna Kea. And the problem is that with all of our street lights and all of our other outdoor lights, it's creating light pollution, which is impeding the ability of the astronomers to see the stars clearly. And as we know, we have the world-class facilities right up there, and we certainly want to promote that. So the solution to all of this light pollution is rather simple, except it's very complex, namely to eliminate that outdoor light which is either going directly up or even going horizontally, and direct it down to the street or to wherever you want it, rather than wasting going up into the sky. And the easiest way to do that is through LED lights, because you can direct LED lights into any pattern you want. And incidentally, as you're doing that conversion, you can reduce your outdoor lighting use by 50%, even 60%. So you have huge energy savings, you eliminate light pollution, and you have better quality light down on the ground. Los Angeles has converted all 210,000 of its streetlights to LEDs. The first neighborhood they started with was the most dangerous, crime-ridden neighborhoods, and the police love it because they can much better identify the bad guys, and from helicopters they can actually see the bad guys running through back lots and things like that much more clearly. Crime has been reduced as a result of this improved light, and LA is saving over 50% of its lighting energy. And it has virtually, not eliminated, but largely reduced its light pollution. So everybody wins all across the board, and I'm very active in that.
Oh, excellent. And I know particularly on islands, there's also the issue of light shining out into the ocean, confusing sea life of various sorts, turtles who are trying to nest, or the young turtles coming out of nests get confused by it.
And we have the albatross, not the Laysan albatross, the shearwater albatross on Kauai, endangered species. During the breeding season, they fly out and they confuse the streetlights with moonlight and tend to circle the streetlights over and over again, get exhausted, drop to the ground, and they either get run over or eaten by cats or whatever. And this is endangered species. Big, 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 big deal on Kauai. So just an offshoot of that is we're wondering which spectrum of light, what type of light attracts the shearwaters, what type of light attracts the turtles, and can we eliminate that from the spectrum so that in essence the light that can be seen by us cannot be seen by these endangered species. And then we can specify light that way. To me, that's exciting stuff.
It is indeed, actually,
Yeah.
that you're speaking to a subject near and dear to my heart. I spent years of my life looking at color vision in fish and seeing what colors the fish were actually able to
Oh,
see.
wow.
So it's I hadn't realized it would tie into energy conservation problems and all. So that's most intriguing.
And
to hear.
then the more wildlife we have, the more attractive it is to tourists. We can use that as a tourist attraction, build our economy.
Absolutely. So that's very very interesting to hear that too. So we should can we play this scenario out where do you see things going in the future here in terms of Hawaii? You seem pretty optimistic about a lot of the projects you're involved in, and overall energy picture you think is reasonably positive for Hawaii then?
Yes, I do. I am the eternal optimist. You give me a timeline for something to be accomplished. I'll say, 6 months, and it's usually a year or even more than there. But I remain the eternal optimist. I see, let's just shift to air transportation. There's now carbon composite materials that are 100 times as strong as steel, weighing 1/6 as much as steel. And guess what Boeing is making its new planes with? Carbon composite. A large part of the fuel use of air transportation is the sheer weight. We're reducing that weight. When we reduce the weight, we become more efficient. The less fuel we use, therefore, the fuel tanks can be smaller. The less weight of the fuel tank, it's a positive. And we're working with renovating the airports so that getting the planes in and out of the airports is much more fuel efficient also. So that takes care of that. Our cars and our trucks are becoming much more efficient. We're using biodiesel much more. Our garbage trucks and our buses are now using 20%, last time I looked, biodiesel locally produced. The grease from the fast food restaurants and so forth gets trapped under the restaurants. It gets sucked up, processed on Sand Island, made into biodiesel, and it fuels military trucks and our buses and our garbage trucks. That will increase as we figure out better ways to do that. And of course, we're shifting over to electric vehicles more and more, and hybrid vehicles, so we're reducing energy use that way. And if I had my druthers about building new homes and new buildings, we could go down to half as much energy use as we are currently using. I don't have my druthers, but we can improve it by 20%. We can go into existing homes, existing buildings, and really dramatically reduce their energy use too. What we're shooting for in homes and buildings is what's called zero net energy, where we take the energy use down to as tiny a fraction as we can, put photovoltaics up on the roof, and produce as much energy as we are using. So that's a short-term goal, next 20, 30 years. Long-term goal, we can become a zero net energy state.
Wow.
Yeah.
We're on break now. Again, I'm Ethan Allen here with Howard Wiig from the State Energy Office. We'll be back in a moment.
Aloha, I'm Nicole Horry for ThinkTech. For nearly half a century, the Hawaii Foreign Trade Zone No. 9 has brought the benefits of the Foreign Trade Zone program to Hawaii businesses and entrepreneurs. DBEDT, the Department of Business, Economic Development, and Tourism, operates Hawaii's Foreign Trade Zone program to encourage international business and economic development. The Foreign Trade Zone's mission is to increase the amount of international trading activity in Hawaii, thereby providing employment opportunities for the residents of our island state. For more information, see ftz9.org. I'm Nicole Horry. Mahalo.
Hi, I'm Ethan Allen. We're on Likeable Science here on ThinkTech Hawaii. I'm here with Howard Wiig from the State Energy Office. We've been talking about all kinds of fascinating ways that the state is working to promote energy efficiency in the face of changing climates. And Howard was just explaining how the state's on what sounds like a pretty good path to energy efficiency. It's amazing, actually, what you were saying to me. Hawaii, as I understood it, perhaps naively, imports just huge amounts of fuel and all, and you're sort of saying that we're going to eventually get down to where we're going to be very self-sufficient for at least a lot of our energy needs.
Yeah.
That's an amazing and very inspiring future to look forward to then. But what about things like, we won't be at 100% electric automobiles for the immediate future. So we're still going to have to bring in some.
Absolutely, yeah.
But you figure that's going to really be dropping fairly substantially in the near future.
It already is dropping. If you look at our transportation fuel consumption, it's actually going down. And you say, wait a minute, there's more traffic, there's more cars. You're absolutely right. We have the highest per capita car truck ownership in the entire nation in these cramped little islands of ours. But in the face of that, fuel use is going down. Why? Our cars and trucks are much more fuel efficient. It's nothing to get a new car and for it to get way into the 30 miles per gallon range. So that's something positive that's happening. All the energy using equipment in buildings and homes are becoming more and more energy efficient. They do a better job with less electricity. If you have a 20-year-old refrigerator and you traded it in for a new refrigerator, same cubic footage with all the new bells and whistles, you would reduce your energy use per year from 1,400 kilowatt hours a year to 400 kilowatt hours a year. That's how technology is improving day after day after day, and that's one of the things that makes me really, really optimistic, is we just have to keep turning over that old junky equipment and getting new high efficiency equipment in here.
Well, excellent. Thank you very much, Howard. It's really, it's a great positive note to end things on here. We are out of time now. I'm going to have to wrap things up. It's been wonderful having you on the show. I very much appreciate all your good insights and all. Again, I'm Ethan Allen here, and you've been watching Likeable Science here on the ThinkTech Hawaii Streaming Network series. I've been talking with Howard Wiig from the State Energy Office, and thanks to Howard very much for being here, and thanks to you all for listening. Please do stay tuned to see Willow Chang come up on our next show. She'll be talking about the art of life. Thank you.